Welcome to review quiz 5, calculus 2, and talk about the tangents to polar curves. So first of all, we find the slope of the tangent line to the cardioid at the point where theta equals to pi over 6. And we are talking about the cardioid defined by the equation r equals to 1 plus cosine of theta. So the tangent line is given by the equation of y equals to mx plus b, because it's like the general equation of a line. So we're talking about the slope. So the slope is given as y2 minus y1 over x2 minus x1, or we just say rise over the run. But because it's a tangent line, it has to touch the curve at only one unique point. So we try as much as possible to, this is like an estimation of using the secant, but we try as much as possible to reduce the distance between x2 and x1, that to make it a small, very, very, very small. So x2 minus x1 will approach 0. And that's where you need to use the limit as x2 minus x1 tends to 0 of the function. And that's the definition of derivative. So we were finding the derivative, and we have the equation r equals to 1 plus cosine of theta. And r now is a function of theta. And then we have x equals to f of theta cosine of theta now, and y equals to f of theta sine of theta. This is the polar representation of x and y coordinates. So to find the slope, we will find dy dx, which is dy d theta times d theta dx. So which is equals to dy d theta is y in terms of theta. And the other equation is dx d theta, but we cannot be able to write, but in the formula is d theta dx. So we need to find the reciprocal of that. So we have dy d theta times 1 over dx d theta, which is written in this form, dy d theta divided by dx d theta. So dy, the function y with respect to theta, it's a product of two functions. So we have f of theta and sine of theta. So to find its derivative, we need to use product rule. So that's the product rule we have used in the numerator. And same case, we apply the product rule to the denominator, and we get that answer. Then we substitute f prime of theta with minus sine of theta, just the derivative of the cardioid, in this equation. So that means we have dy d theta equals to, after substituting, we have all that. And then we are finding the slope at a point theta equals to pi over 6. So we substitute theta with pi over 6. And after simplifying algebraically, we have that the answer equals to -1. Remember, we need to use, without using a calculator, to use this triangle of 30, 60, 90 degrees special triangle. So that's the number 1A. Number 1B is locate all the points, or locate the points on the cardioid where the tangent line are horizontal and vertical. So to be horizontal, we need to set the whole function to 0, dy dx equals to 0, specifically the numerator to 0. So that's why for the horizontal, we have set dy d theta equals to 0. And then, so we have cosine squared of theta minus sine squared of theta plus cosine of theta equals to 0. But we know that sine squared of theta, they have a relation with cosine squared of theta. So sine squared of theta equals to 1 minus cosine squared of theta. And then we simplify to have 2 cosine squared of theta plus cosine of theta minus 1 equals to 0. And this is a quadratic equation. If we let cosine of theta to be equals to x, we'll be having this quadratic expression in terms of x. So simplifying that, we have that x equals to 1/2 and x equals to -1. So the angles, because we have x equals to, cosine of theta was equals to x, so cosine of theta equals to 1/2 and cosine of theta equals to -1. So the angle that gives you 1/2, it's pi over 3, and maybe another one cycle, we have 5 pi over 3. And then the other one that gives you -1, it's pi. So these are the angles of consideration. Now, for the vertical, we set the denominator to 0. That means we have -2 cosine theta sine theta minus sine theta equals to 0. If factor out minus sine theta, we'll be having in parentheses 2 cosine of theta plus 1 equals to 0. That means that sine theta equals to 0 with a minus, but minus can be eliminated because you're dividing by a -1 on both sides. Or 2 cosine of theta plus 1 equals to 0. To have angle to be 0, it's 0 and pi, or cosine of theta to be -1/2. That means that the xy value is minus and the y value is 2. So that if you are to draw a unit circle, let me sketch a small one. The quadrant whereby x is minus and y is positive, it's the second quadrant, and it's only sign which is positive. So the angle that is in the second quadrant, we know that cosine of theta, which is the minus pi/2, so cosine inverse should give you, first of all, we assume minus is not there. So cosine inverse of 1/2, it's 60 degrees. We saw that one. But in the second quadrant, it should be 120, which is in terms of radian, 2 pi/3. So another one cycle, we have 4 pi/3. So those are the angles we need. But let's check. We can check all of them if they satisfy to be the horizontal and the vertical. But the checking, we only find that all of them are there. But at theta equals to pi, if we substitute theta equals to pi in our derivative function, we find that it's indeterminate form. If you do that for dy dx, if you go ahead and substitute theta equals to pi in our work, well, in our derivative, we find that the answer becomes indeterminate. So, and for that reason, we need to find the limit or to solve that one, dy dx, if we find the limit as this tends to 0, so if as theta tends to pi on both sides of dy dx using L'Hopital's rule, we will get the answer. So this will give you that dy dx will tend to 0 as theta tends to pi on either side. And that's when we conclude that indeed theta equals to pi. Once we impose limit, it's a horizontal tangent. So the answer for the horizontal tangent will have the pi, but for the vertical tangent, we will not have a pi. Let's go to part 2. Find the area of the region enclosed by r equals to cosine of theta. So for r equals to cosine of 3 cosine of theta, if we are to sketch, we find that this is a circle. Not a good circle, but I'll try and get a circle. A circle of diameter from there up to here, 3. So that's a circle. So to find the area, we first of all need to get the limits. To get the limits of integration, we will set R to 0. So R to 0. So we have 0 equals to 3 cosine of theta. So cosine of theta equals to 0. And then the angles that gives you theta to be equals to 0, it's 0. No, it's pi over 2 and minus pi over 2 if you are to do one cycle. So the integral will be doing minus pi over 2 to pi over 2. And the formula we have, if you derive, it's a half f of theta squared d theta. So this gives you the area. So the area equals to minus pi over 2 to pi over 2, the function 3 cosine of theta squared with respect to theta. And we still have a half. So this one becomes 9 over 2 because 3 squared is 9. Then we integrate from minus pi over 2 to pi over 2 of cosine squared of theta t theta. So to integrate cosine squared of theta d theta, we need to reduce the power using the reducing power formula, or let's use the double angle formula, and then we reduce the power. And we have that cosine squared of theta is always given as a half 1 plus cosine of 2 theta with cosine of 2 theta, sorry. So the answer for the area here then becomes 9 over 2 integrate from minus pi over 2 to pi over 2. Then a half 1 plus cosine of 2 theta with respect to theta. So this gives you area equals to 9 over 4 integrate from minus pi over 2 to pi over 2, 1 plus cosine of 2 theta with respect to theta. And this becomes 9 over 4. The integral of 1, it's theta. The integral of cosine of 2 theta, it's sine of 2 theta divided by 2. And the limits of integration are minus pi over 2 to pi over 2. So simplifying using fundamental theorem of calculus, you have that the answer is 9 over 4 pi. That's the end of the review quiz.